Hello friends, welcome back to the latest video on Start Pro for fresh civil engineers. Up till now we have completed the analysis of simple trusses. Now in today's video we are going to discuss the analysis of some standard trusses. In our last video we are analyzing this simple triangular truss as well as we are analyzing this kind of one truss. Now in today's video we are going to discuss some kind of these type of standard truss models, right? Now here in figure you can see here a truss A, B, C, D, E, F, G, H, I, J is there, gets subjected to 20 kN lateral force and supported at A and at J. The horizontal span is of 3 meter and the vertical span is of again 3 meter. So now let's analyze this by using the Start Pro. Let's create here the new plane. Here I am considering the truss 3. Now you can select over here as a truss also, add beam, finished. So this kind of beam is appeared on the screen. Let's consider the front view of that. Right now here the total span is 3 plus 3 plus 3 plus 3, 12 meter, and then vertically it is 3 meter. So here I am increasing the grid size horizontally up to 12. Okay. Now let's draw the beams. 1, then 2, 3, 4, then vertically again 3 meter. 1, 2, 3, 4, right? From the grid view, let's just delete these additional node points, selecting the node cursor, delete, yes. Okay, then one more this one, yes. So now add the beam. Now again this truss is also you can add by using the translational repeat command, right? Now let's add the beam here, vertical beams. You can draw the first block and then you can horizontally in X direction you can repeat that block, right? Now these are the inclined members, A to C, C to F, then here F to G and G to J. So here let's join these inclined members, add the beams. Okay, now this is a model of the truss. Now let's next is general. Pick the property, go in the section database. As we are assigning the steel section, select here Indian. Then now let's take this time as a I section. So considering any I section size, okay, add over here, then close, assign to view, assign, yes. So all the members are of I section. Next is support, add this pin support, then add this fixed part, fix and set movement, add that support. Now use cursor to assign, select this node, assign, then the roller support, assign, yes. Next go to load and definition, load case details, add the load case 1. Now here in load case 1 further add the nodal load in X direction of 20 kN, add over here, close. Now assign this cursor, assign to selected node, assign yes, right. Can display the value also again. Now here display the load value. Here you can display the beam number also as well as the node numbers also here, or node points also. Okay, apply. Okay, next, now analysis and print, select all, add over here, then close, select this, assign. Now run the analysis, save. Okay, so 0 errors and 0 warnings, done. Now let's go in the post processing mode, apply. Okay, you can see here this is a deflection curve for the given truss. Then similarly you can view over here the bending moment diagram. Again there is only point load, so bending moment diagram is a linear load. Then here a shear force diagram. Okay, then as per the here reactions are there, x direction reaction 20 kilonewton, and y direction there is a reactions of -5 and +5, so summation of Fy is 0. Then when you are selecting the beam reactions, go in the beam forces, when you are selecting this beam, then here you will get the reactions or the forces in that particular member. You can select any member to find out the reaction forces. Even this inclined members also reactions are -5.808, then -0.060, right. Whenever there is a minus sign, it means that that member is in compression. When it is a positive, then that member is in tension, right. Okay, now you can also plot the report also as per the required information of input and output. Okay, now this is one of the way by model the truss by using this adding the node and adding the beams. Now in case of trusses, if you see in StatPro there are some predefined standard models of trusses are given, so through that also you can directly import the standard truss models. Like for example, here this is one more truss model, you can try the analysis of this truss. Now here this is the truss model of Pratt truss. Pratt truss is a standard type of truss which is used in case of the bridges. So now here instead of doing the modeling of adding the node and different beams, directly also you can import the Pratt truss model in the StatPro. Okay, let's see how to do it. Here I'm just closing this. Let's open the new task, plane over here. Then I'm considering here the truss. Let's say 5. Next, finished. Okay, now for that purpose you have to go in the geometry. Then in geometry the last option is there, run structure wizard. When you click on this run structure wizard, here you can see there are truss models provided. Now in that a Pratt truss, Warren truss, Howe bridge, lattice truss, Howe roof, north light. So this type of the standard truss models are already given or provided. You can see over here that whatever the truss model we are thinking, that is this inclined member, then this inclined members, and then this is a type of Pratt truss model. You can parallelly compare those things. So instead of adding the node and beam, if I am selecting here Pratt truss model, this window is displayed. So model name is Pratt truss, length of the span. Now here the total this window. Okay, now you can see here the total span is 3 plus 2 5, then plus 5, so 2 bays are there, 5 and 5 meter. So here the total span is 10 meter, height is given 3 meter, so I am putting over here height as a 3 meter. Now width, we are considering a single, so we are keeping the width as a 0. Now let's try if you keep the width, what happens. Okay, if I am keeping it here 10, now number of bays along the length, so here let's say initially I keep the number of bays as a 3 and the bays along the width, let's take here I am taking as a 2 and then apply. Okay, now here you can see that Pratt truss along the length I am selecting here 3 bays. So here you can see, let's count here the first bay, then this second bay and this third bay. Bay is nothing but the one triangular element, so first, second and third. So I am putting here the number of bays along the length is 3. If you check over here, the number of bays along the length is 3 and number of bays along the width, so here along the width there are 2 bays are there, so this will be the one bay and this will be the second bay. Okay, now here if I am putting the width as a 0, I am keeping the number of bays as a 2 and number of bays along the width as 0. Apply over here. Now you can see this type of single truss that will be appeared on the screen, which is required by us. Now here you have to go in transfer model. Okay, so select over here transfer model. Yes, now in transfer model this window is get open. Now here there are two options, move prototype model. Now here there is option of by distance between the two nodes. Suppose we are already created one structure of column and all that, and now we want to put this or insert this truss model at particular node, then in that case this option is useful. Now here there, as we are not having that original or already model, so directly we are keeping this XYZ values as a 0 0 0 and select over here. Okay, now you can see here that Pratt truss model is transferred in this stat. So here closing this grid view, now here you can see the model is directly appearing on the screen, so there is no need to add the nodes as well as add the beams. Now directly you can further follow our regular procedure. So property, then select over here section database, then here selecting the Indian, I am considering here I shape, selecting any one I shape size, add over here, then close, assign to view, assign, yes. Now next support, so in the given model there are two supports, at A pin support, at E roller support, and 3 vertically downward load 6 kN, 10 kN and 6 kN. So let's go there. So support, creating pin support, add, then creating the roller support, fixed bar, FX and MZ, add over here. So assigning pin support, use cursor to assign, assign, yes. Then assigning the roller support, assign, yes. Okay, now let's go to the load and definition. So add the load case details, add over here load case 1, close, in load case 1 add the nodal load, so vertically downward minus 6 kN and minus 10 kN, close. So 6 kN, use cursor to assign, so I am assigning it, selecting the node cursor, assign, then at this point, then 10 kN over here, right? So all the 3 loads that will be get assigned over here, whether it will be applied at the downward side or over here doesn't matter, the effect will remain same. This is the principle of transmissibility. Okay, so now here loads are get assigned. Our next job is analysis. Perform the analysis. Till you perform the analysis, your run analysis will not be done. So here initially you have to perform the analysis and then go in the run analysis. So save. Okay, 0 errors, 0 warnings, and it will be done. So let's see the post processing mode. Okay, now you can see here the reactions at the support as well as in the beam. You can check over here. This is a bending moment diagram, right? Then here you will check the shear force diagram. Press the control button and scroll the bar. You will get the reduced or increased view of the shear force and bending moment diagrams. Now in beams further you can also see the graphs over here like mz, fy, fx, like nothing but the forces in that members. Okay, now even in the output file here applied load and reaction load, here you will see all the members. If you know the member of the beam, then in that case you will came to know the forces as per the beam number over here. That is, these are the joints node numbers, then the forces and those members over here. So in x direction and in y direction, all that. Over here external and internal joint load summary. Okay, so here by using this geometry, we are going in the modeling mode. So geometry in run section wizard, this is very useful as here number of truss models are already provided. Similarly, if you go for frame models also, then this type of braid frames, grid frames, then continuous beam, then circular beam, all these beams are also get provided. So if you are selecting here bay frame, here they are asking for length, height, width, number of bays along the length, along the height, and all that. Just you have to put these details and then immediately the complete model is generated within a fraction of seconds, and that model you can directly transfer to the STAD. So next job is just application of load and application of support conditions, and you can immediately get the result for the forces in the different number of members. Okay, so now you can do the practice of solving this analysis of truss models as well as frame and all. Now we are just left with the design of 1G+3 RCC building. So in the next upcoming videos we are going to see that the design part, and we are going to completely design 1G+3 RCC building. Okay, so till that, thank you very much.